Hello and welcome everyone. My name is Seng and my partner is Muhamad Abubaker. We are from BFT Group 6. Today I'm going to talk about the fundamentals of computer networks assignment that is assigned to us. Today we will talk about the introduction, the network design, the subnet design, the address design, the network configuration and the digital resources used by us in this assignment. First off, the scenario provided to us. As network engineers, we have been hired by TechX Network to design and set up a local area network that spans multiple locations. Those locations are location A, B, and C. In location A, there will be our admin department, sales department, and customer service. 500 meters away from location A is location B, which has the gaming tech, big data hub, and cyber security facilities. And then 200 meters away from location A is location C, which is our research and development labs. This is the network design that we have came up with. There are a total of 10 subnets, one subnet for each facility and department, and then 3 will be reserved to connect the routers between routers. The router model we have used is the router PT, and we used it because it has the relevant modules that we need to connect fast Ethernet and gigabit Ethernet. The switch model we use is 295024 because it has 24 ports in the switch. It will be very useful in our network with a large amount of hosts. The transmission media we use to connect the router between the routers is fiber optic. This is because it is suitable for long ranges and is immune to interferences. And we use copper straight through to connect PC to switch and switch to router. The port we use to connect the routers between the routers is gigabit Ethernet port. This is because gigabit Ethernet can support up to 1000 megabits per second transmission data. This makes it very useful for router to router communication. The port that we use to connect PC to switch and switch to router is fast Ethernet port. This is done in consideration to the cost of actually installing this network. As there are large amounts of hosts in the network, it will be very costly to use gigabit Ethernet port for every single host connected. These are the number of hosts that are required in each of the department and facility subnets that we have prepared. But we will need to account for 88% of growth for all of these hosts. So, how do we calculate the actual number of hosts after expansion? We do so by first locating how many hosts are in the subnet, and then we find out how much of the growth actually is. We need to total it up by adding them with the original host number to get the total number of hosts after the growth. We do this for every single subnet to find the total number of hosts in each subnet. This is our subnet design. The subnetting method we use is FLSM, which is fixed length subnet mask, making it all the subnets will have the same size and same subnet mask. We will use the largest subnet group to find our subnet mask, which is the admin department we can see here. It has 384 hosts, which is the largest amount in a subnet. We do this to make sure that every single subnet will get usable IPs for every single host. In the subnets, the first IPs will be reserved for the subnet address, and then the last IP will be reserved for the broadcast address. This leaves us with a range of this number for the usable IPs in the subnet. In order to calculate the subnet mask, by using the number 384 hosts, we use it to find the closest larger number of host bits required. The number of bits preserved for hosts we will get is 9 bits because 9 bits is 512 IPs. However, since the first IP will be reserved for the network address and the last IP will be reserved for the broadcast, the actual number of usable IPs we get per subnet is 510. Since we have preserved 9 bits for the host address, the remaining 23 bits will become the network bits. Thus, the custom subnet mask will be 255.255.254.0 with the prefix of 23. With the IP being a Class A network, the default subnet mask will be 255.0.0.0, which is of the prefix length of 8. By taking 23 host bits and then minusing the default 8 bits, we will get a number of 15 bits. This is the number of bits that we have borrowed and the number of bits that will become the subnets. While this is a lot of subnets, we will only use 10 of them for our current design, and the rest will be reserved for future users. After finding out the subnet mask, we can use it to find the subnet addresses for each of our subnets. We will need to find the increments of the subnet addresses. We will highlight the largest host bit in the subnet mask and taking note of the octet location and the bit size of the octet. In this case, the largest host bit is located in the third octet with a bit size of 1. By converting it into decimal, we get the increment of 2 at the third octet. With this, we can start finding out the subnet addresses of the subnets. The first subnet will be the network address that is given, and then for the rest of the subnets, we can count by using the increment. So for the second subnet, we plus 2 at the third octet, and then for the third subnet, we plus 2 again, and then 2 again for the next, and 2 again for the next, and so on, until we find all the subnet addresses for all our subnets. This is our addressing table. This table will show the devices ports, the IP address of the ports, the subnet mask, and the default gateway. For router interfaces, their IP will be assigned to the first usable IP of their respective subnets. Same goes for all of the other interfaces which are connected to the subnets. There are special cases for these gigabit Ethernet ports. They are the ports that connect routers to routers. So for gigabit Ethernet 4, it connects router 1 to router 2. This is the addressing table of the switch section. The IP addresses are configured to the VLAN port of the switches. The switch will have an IP range of 10.0.x.2 until 10.0.x.21, which is a total of 20 IPs reserved for the switches. This is because in a real environment, the subnet will have 384 hosts, which one switch is not enough to handle. We have planned that we will use switch-to-switch connections to connect the switches to switches together, and then the end hosts will connect to the switch. So we will reserve 20 IPs for the switch in consideration of the real environment. So following this scenario, the switch will get the second usable IP of the subnet, which is 10.0.x.2 for all the switches. The default gateway of the switches will also be set to the corresponding router interface port of their respective subnets. This is the addressing table part of the end devices. The end devices will use the last usable IPs and then descend from there. This is done to avoid situations where collisions in the addressing strategy. The default gateway of the PCs will be router interface ports of their respective subnets.
Okay, so my name is Muhamad Abubaker. I'll be taking over this part of the presentation. So before we get started, I will first show how to configure the passwords for the router. So what we do is we will go inside to our password, to our router. We go into configuration mode. So now we go into config terminal. We will select the line console 0. Now we just use the password CLA33, login, exit. And then now I will also set the secret password for the I will set the secret password for the configuration mode, the privilege mode. So secret AACS. Okay, and done. Alright, so now I will configure the IP for the first port. So this is done by going into the config T again, using the command interface, choosing the port we want, and I will assign the first IP address of the subnet, which will be 10.0.0.1, which is the administrative department subnet, followed by the custom subnet mask 0.0, and then I put no shut just to ensure that the port is up, and that is it for the router IP configuration. So now if I go out, so now, okay, next what I need to do is, since we are using more than one router, I will have to configure the routing information protocol, or RIP for short, which is the one that we are using. So I will configure for this subnet alone. So what we'll do is go into our config T, and now we will type in router RIP, which is the one we're going to use, and this is done by assigning the subnet. This is done by using the subnet address. So we put 10.0.14. So by assigning the subnet to this, by assigning the network address to this RIP, the router will then know that this router is its neighbor, and it will dynamically use the best path to send data across the networks. So I just press yes, and we're done. That is it for the routing protocols. So if I were to use the show run, so we can see that this is our routing protocol and the subnet and the IP address that we assigned to just now. Okay, so now I will move on to the switch. Okay, for the switch, I will need to assign two things, which first is the IP address, and secondly is the default gateway. CL. Okay, so now I'm going to enable. This has already been configured with the password, so now I will just use IP. Go to config T, interface VLAN 1. We will assign one IP address to the entire switch. So now I will now assign the second usable address. Just 10.0.0.2, which is the second IP address, followed by the custom subnet mask, and no shut again. And we are done in terms of assigning the IP address. Next, we need to assign the default gateway, which is needed for transmission of data across two different networks. So now I will assign the default gateway. I need to fix it, and then use IP default gateway, followed by the IP address that we assigned to the router just now, 10.0.0.1. And that's it for our default gateway. And that is done for the configuration of the switch. So for next, our PC, we will need to configure the IP address. As you can see here, I've already configured it. This is by using the assigning one of the usable IP in the subnet, followed by the subnet mask and the default gateway again. So now I will do the pinging. So what we'll do is, I will ping from this location to the location B, just to show that the routing protocol works. So I will ping gaming tech here, which will be 10.0.7.253. And as you can see, I got a reply from the PC, from the Cyber Gaming Tech PCS. Now we can see that it is configured correctly. So now I'll ping another device just to show that it works. Maybe I will ping the one down here in location C, which will be 10.0.13.253. And we also get a reply 253. It is our PC71. So our pinging is now successful. So that is it in terms of the network implementation. Now moving on to our last slide, which is the digital resources used. We use all of these resources to do our assignment. YouTube, we used it for looking out on senior assignments and seeing how did they record their video or what was the content of their videos. Google Docs and Google Sheets were used to do the assignment. Google Docs was used to assemble the report, while Google Sheet we used it to do the calculations in a table form. Cisco Packet Tracer was used to implement the whole system without using any physical equipment, a good simulation tool. And Google Meet was used with to do our discussions. Mostly our discussions use Google Meet, as it's a good it's a free video collaboration tool, and OBS is used to record this presentation that you are watching right now. And that's it for our entire presentation. Thank you.